Ow! I think I just got shocked. This is Dr. Nick from the ECG Academy, and we're going to talk about how do we record electrical events in the body, because it's very important that you understand these kinds of recording systems in order to be able to figure out how ECG machines work and the kinds of things that can go wrong with them. And it's really a basic concept in learning to read an ECG. So we'll get rid of our little voltmeter here. And we'll start to talk about circuits again. Just like the last lesson, we're going to talk about basic circuitry. This is the last time we'll do this, so don't worry. We're going to get to the good stuff soon. Anyway, a regular circuit would consist of a battery. This would be the negative end of the battery, and the battery would provide the force that would push electrons through the circuit. You could have a switch here that would control when the electrical energy flows, and then the electrical symbol for a resistor would look like a little squiggle like that, and that would be your body or anything inside your body. And then we have to have a means of measuring the amount of electrical energy that's flowing through the circuit. So I put down sort of a symbol for a voltmeter of some sort. So nothing happens when the switch is open, but when you close the switch, current flows through the circuit, and the voltmeter will pick up this flow of energy. Okay? So that's fine if you're an electrical engineer. But when we're dealing with human electrical recording systems, we have to think in terms of bodies and how we record electrical events in the body. And if you've ever had an electrocardiogram done, you know that they use little sticky electrodes that go on your skin to pick up the electrical signals. So we need to understand how we're able to record electrical signals from the body. And there are generally two ways of recording electrical events on the surface of the skin or inside the body, in fact. And those two ways are unipolar recording systems and bipolar recording systems. And we'll talk about the differences. It's important to understand the concept in ECGs because it lets you figure out how to interpret the tracings. Imagine you have one of these sticky electrodes and this on your body someplace, and there's a wire, and that wire leads to a sort of a fancy voltmeter. And then the other end of the voltmeter, well, it's connected somewhere, and the electrical symbol for a ground is this, because that's just sort of handy. With this unipolar recording system, and it's named that because there's one pole that's recording the electrical activity. What the system does is anytime the electrical voltage at this pole is different from the ground, then that records something. It registers on the voltmeter. So, a voltmeter would be normally looking like this somehow, but remember in electrocardiogram, we're going to turn this voltmeter on its side, and we're going to sort of use a pen to record the electrical activity on a piece of paper that happens to be moving. All right, that's sort of the basic concept here. But now imagine what happens if a bunch of positively charged ions, say sodium or whatever, some electrical event is traveling. It has to be traveling towards this recording system. Now, initially, you would not actually record any voltage difference, so you'd kind of have this flat line that's coming out of this recording system. But now what happens when this positive charge stuff kind of reaches this electrode is now the voltage is going to be different at this electrode versus down here at the ground. And what will happen is this voltmeter will register a positive deflection. And as the positive charges gradually move away, once they leave the area, then what will happen is the voltmeter will return to a zero state, and then these things can go on and move away. So that's how we're able to record signals using this kind of a unipolar recording system. Okay, so now what happens if instead of this sort of like generic ground, we use a second pole? We use another electrode, let's say over here, and we connect this electrode to the other end of the voltmeter. Okay, so you still have this voltmeter, but now what it's doing is recording the electrical difference between these two poles. So anytime one pole is different as far as the electrical charge surrounding it is concerned, then it's going to register on this voltmeter. So we have two poles. What do you think? That's right. This is called a bipolar recording system. Okay, so let's erase this whole thing. We still have our voltmeter, but now we have to bring our positive charges back. Okay, so now let's say our positive charges are back over here again. Right now, there's no electrical difference between these two poles, and so our voltmeter is just measuring 0 volts. So now the positive charges come by, and you have this electrical event that's sort of moving. And the first thing that's going to happen is it's going to hit that first pole. And so the first pole is now going to be more positive than the other pole. And so what happens is the signal is going to measure a positive deflection because you've got voltage in this one sign here. As the positive charges move forward, what can happen then is both poles receive the same signal, the positive energy here. And what happens is now the voltage will go back to 0. But as the positive charges continue to move, now the other pole will be more positive than the first one. And the sort of the polarity, as we say, reverses itself. The voltage now reads negative compared to the first event. And then, of course, you can imagine what's going to happen as this signal continues to pass. Now there's no voltage difference, and our signal returns to the 0 volt baseline. So you can see that bipolar recordings tend to be a little bit more complicated because now you're dealing with signals that may hit one pole and then the other first. Okay, now let's change things a little bit. Let's take our charges and imagine that they are traveling in a different direction. What do you think would happen if the charges are now traveling towards the two poles at the same time? As these charges reach the two poles at the same time, there's going to be no electrical difference between the two poles. So what do you think it's going to show? Well, maybe very little deflection, if any. And then as these charges continue to move, as long as both poles remain at the same voltage, then there's going to be very little signal that's recorded. And so in some ways, bipolar recording systems are more complicated because they are dependent on the direction of the electrical signal that's traveling. If it's traveling along the same direction as the poles are, you'll record a very large signal. But on the other hand, if it's traveling in this direction, which would be considered perpendicular or at a 90-degree angle to the recording bipole, since this is a bipolar recording system, we refer to these two electrodes as a bipole, then the signal will barely show up on the recording. And that allows us to, in some ways, determine the direction of the electrical signal as it's traveling. Okay, so ECGs, for the most part, are using bipolar recording systems. Each bipole that the ECG uses is known as a lead. And we're going to talk more about this because when you have a full-blown electrocardiogram, it's known as a 12-lead ECG. But you have to understand the idea behind a unipolar recording system with one pole. It's very sensitive to pick up electrical activity that comes in any direction. Bipolar recording systems are able to pick up electrical signals very well as long as the signals are traveling along the direction of the two poles. But if signals are traveling perpendicular to that recording pair or that bipole, it may have a hard time picking that up. All right, so that's the two different recording systems. And now that we've gone over this sort of basic electrical theory, we can start talking about the heart and about electrical events that occur within the heart and how we record them and how we interpret them from the ECG. Well, thanks for listening. This is Dr. Nick with the ECG Academy. And please subscribe to my YouTube channel and check out ecgacademy.com. It's going to have a whole host of videos that will teach you how to become an ECG expert. And thanks for watching.